Now, let's learn how to customize the cost-benefit analyzer on Aqueduct floods. The very first selection that you'll make in this customized analysis is selecting your location of interest. So to do that, you simply just click in this box and you can start typing in the name of a major river basin, country, or state. So in this analysis, I'm going to look at the country Mexico. You can also select the future scenario that you are most interested in. We have three different options to select from, and these represent a different combination of carbon emissions and socioeconomic development pathways. The pathways are defined by the IPCC's CMIP5 dataset. And if you're curious to learn more about the exact definitions of each scenario, simply click on our info button to learn more, and you'll find the definitions and the source within that info box. So once we select the location of interest, we can move on to actually designing the proposed flood protection infrastructure. And remember, this infrastructure is specific to gray infrastructure, so dikes and levees. It's not looking at green or nature-based solutions yet. So the first thing you'll need to do is assign the existing level of protection. And we're defining this using the return period. This is also known sometimes as the recurrence interval. It's essentially the probability of an event happening in a given year. So for example, when you see 25, return period of 25, that's saying that the existing flood protection can protect against floods up to a 25-year flood. So that's, a flood that's expected to happen once every 25 years. Another way of saying that is these floods have a 4% probability of occurring in a given year. And we offer an estimate for every state around the globe, but we acknowledge that you might be more of an expert in this location and you want to customize the level of existing flood protection. So let's say that you're more familiar with Mexico than I am, and you think that the existing protection within the country on average is around 20. So it's protecting up to 20-year floods. And as we're looking into the future, let's say we want to be able to protect against 50-year floods. Now, when we're designing that future flood protection level, it's really important to assign a time period for that. And that's because the climate is changing. And that means the intensity and frequency of the flood hazard could also be changing. So what could be a 20-year flood today might actually be a 10-year flood in the future, meaning it has a higher probability of happening. So what we're saying in this analysis is that we want to design a flood protection infrastructure that will protect against floods up to 50-year return periods in the year 2050. Now that we've designed the infrastructure, we need to think about what it would take to actually build that infrastructure. So the first part of that is understanding the implementation range. This is simply the time period it's going to take to construct that infrastructure. So again, for all of these things, we offer defaults. The time series analysis for this CBA starts in 2020. So we might say, okay, we think it's going to take about 20 years for this dike and levee infrastructure to be built. That's what this implementation range is saying. We can also specify how long we think this infrastructure will be active. How long can we receive benefits from this infrastructure, right? It may be around past this lifespan, but we might not really be seeing the benefits. So we can specify that here as well. And then finally, we can also say when we expect to start seeing benefits. And you'll see that the range of this analysis or this selection is actually the bounds of the implementation range. And that's simply saying, listen, it might take 20 years to build the infrastructure, but we expect within 10 years that we'll start seeing some benefits as the infrastructure gets higher and higher. It's going to start protecting. So we can specify that benefits start year. Now, the final element to setting up the CBA analysis is specifying the cost associated with the infrastructure. So if you remember from my calculations conversation, the first thing that we have to say is what is the cost to construct infrastructure in this country? Um, we set a default for you per country. What 88% means is that our standard or baseline that we use in the analysis is centered on the United States, where we say it costs $7 million per meter depth per kilometer length to construct infrastructure. But that number, that unit might not mean much to you. So maybe you're just going to say, okay, well, I'm in a different country where I think it costs less to construct infrastructure. I think it's, 12% less to construct in this country than it is in the United States. So that's the way that you can interpret this selection. The final selections are about the discount rate and the operation and maintenance cost. And if you have questions about what these terms mean, again, you can refer to our info button. So for example, the annual discount rate represents the rate in which present value will change through time. And I'm going to leave that as the default. But for the O&M cost, I'm going to increase this to 2%. And that's saying that every year, I'm going to take the cost to construct the infrastructure, the total cost it takes to build this thing, and I'm going to apply a 2% tax essentially on top of that. And that's going to cover the operation and maintenance costs. It's a proxy and estimation, but we want to make sure that we're capturing those and not just focusing on the cost to construct. So once we make all these selections, we can hit apply changes. But before I do that, I actually want to show you one more feature, which is the compare with. And here, it makes it really easy to run two different analyses at the same time. So I'm actually going to select Mexico again, and I'm going to make everything exactly the same, except for the level of protection. So in the first analysis, I want to build infrastructure that protects against 50-year floods in the year 2050. In the second analysis, I want to increase that to 100. And I just want to be able to compare the cost and benefit of these two different proposed infrastructures. So I'm going to keep everything else the same. I'm going to move my benefits to start in the same year that I had. And I'm going to make sure that my O&M costs are the same. And then I'm going to hit this button, Apply Changes, and it's going to calculate. And this is a custom analysis, so it is calculating on the fly. You might be a little frustrated that it's taking some time, but I promise it usually takes about a minute to run. And if you're patient, you will see the results appear.